In this lesson, we are looking to Pure 2, Chapter 5.4, where we're looking into solving trig equations using radians. So, we are going to use the cast diagram like what we used to do in year 1, and then, but this time instead of degrees, we just use radians. So it will be a little bit weird for some people to start with. However, you'll get used to it. Okay, right. So let's have a go. Solving trig equations in radians is not too different from year 1, where we are going to use the cast diagram. Now, some people like to use a different method, like if they remember the formula, for example, for sine will be 180 degree plus something, 180 degree plus the angle. With cos theta will be negative theta. So there's some formula you can remember, but I don't use that way. I teach it through a cast diagram. If you're not sure with what's cast diagram, you can go back to the video about cast diagram in year 1. That's chapter 10 in Pure 1. Next one, part B, we can use the radians. We know radians is in 2 pi instead of degrees, which is 360 degrees. So all works the same when finding other pairs of values. So it all works the same, but it's just in radians. So slightly different. Starter. Okay, so starter, you should, if you're confident with your cast diagram, this year 1 trig equations, you can pause the video, have a go with the question. Okay, when you're ready for the answer, you can press play. Right, so here are the answers. So theta equals 10, 110, 130, 230, 250, and 350 degrees. That's the final answer. If you got it right, well done. You can move on to the next example. But if you don't, let's go through it, okay? Just a bit of a recap on cast diagram before moving on to the harder stuff. Right, so it's like, starter before we go into the main dish. So solve cos 3 theta equals root 3 over 2. The first thing we need to do is we do the inverse cos. So 3 theta equals inverse cos of root 3 over 2. Inverse cos is also known as arc cos. So if I just say arc cos, you know what I mean. So arc cos, you'll actually learn it in chapter 6. So arc cos, inverse cos, same thing. So when you put in a calculator, inverse cos of root 3 over 2, you should get 30 degrees. So 3 theta equals 30 degrees. So cast diagram, that's how it works. If you don't know, CAST. So 30 degrees is here. Okay. For cos theta to be positive, I'm going to reflect it into the C quadrant in here, 30 degrees. Okay. So using cast diagram, I know my answer from here. So 3 theta equals to, if I go clockwise direction, that's 30 degrees. We know that's 0 degree, by the way, 0 degree. And we go all the way in here, that's the same as 330 degrees. So therefore, 3 theta equals 30 degrees or 330 degrees. So that's the first thing we do. That's how we use cast diagram. So from here, that's how we use cast diagram. So when do you use it again? Well, we use cast diagram as soon as we are using inverse sine, inverse cos, or inverse tan. All right. Next, what we also need to take care of is the 3 theta, because 3 theta means the domain from theta from 0 to 360 now will be expanded into 3 theta. We have to multiply by 3. So 3 theta is less than 1080 degrees and 0 degree. Now you see our 330 and 30 degree is way below 1080, which is our maximum value, maximum degree, with the highest, the maximum range. So what can we do to find more answers? We can add 360 to find more pairs. So we keep adding 360 until we reach the limit of the domain. So add 360 to 30, which is 390 degrees, or 330 plus 360 is 690 degrees. Again, 690 is still a bit off from 1080, so we keep adding 360 degrees to it. So if we add 360 to 390, that will give you 750 degrees. Or if you add 690 to 360, that's 1050 degrees. Now we realize 1050 is very close to 1080. So there's really no point to add another 360, because we know once we add 360 to 750 or 1050, that will go beyond 1080. So these are my values, okay, 6 values for, these are my 6 values for 3 theta. Don't forget the left hand side is 3 theta. So to work out the value for theta, I just have to divide everything by 3. So theta, divide everything by 3. 30 divided by 3 is 10. 110, 130. 690 divided by 3 is 230. 750, 250. 1050 is 350. So these are the answers, 6 answers. Okay, this question, I think Edexcel would carry 5 marks, 6 marks. Right, next one. So next one example, where we do sine 3 theta equals root 3 over 2, but this time is in the interval from 0 to 2 pi. From last example, we've learned that we need to expand the domain. So times it by 3 becomes 6 pi. Now, I think personally it's also worth writing down degrees next to it, just so it reminds you how many times you have to add 360 or add 2 pi. Okay, so if you do 6 pi in the calculator, we know, remember pi is 180 degrees, so 6 times 180 degree is 1080 degree. So I know that's my cap. Okay, 6 pi is same as 1080 degree. I guess no one in here is very familiar with radians because, well, even though you're familiar, you are only so familiar from year 12, right? Some of you might learn ahead in year 12, but you never learn about radians in GCSE. So I think people tend to prefer degrees, and that's fine. You can work in degrees and sort of change your answer to the radians at the end, but in the middle, you must show steps about radians. So on the side, you can do some jottings about degrees, but in the main working, you must be using radians. So, or, it's good to be getting used to radians, because if you do anything with maths further on, later on, uni level, you'll be using a lot of radians. Right, so sine 3 theta equals root 3 over 2, same thing. Okay, so first step, we're going to inverse sine, arc sine of root 3 over 2. Okay, put it in a calculator, that will give you pi over 3. Remember, calculate has to be in radians mode. Okay, so 3 theta equals, put in a calculator, pi over 3. Now, I like to use some, pencil in my working out just to show, okay, pi over 3 is 60 degrees. So just so I know in my head, where is pi over 3? Because pi over 3 does not tell you where it is on the class diagram unless you use degrees. So 60 degrees now I know is here. Okay, I can do pi over 3. If you really prefer, you can put a 60 degree in here, just so you know. Right. For sine to be positive, I need to reflect it on the quadrant that sine is positive, aka the sine quadrant in here, and this will be pi over 3. Right? What else do we need to know? Well, we know in the class diagram that's 0 degree or 0, pi, and then this is 90 degree, this is pi over 2, and this is 180 degree, or pi, or just pi, and there's 270 degree, that's 3 pi over 2. Okay, right. So to work out the other value, the orange one in the sine quadrant, normally I would do 180 degree minus 60, but because in radians, the other answer would be pi minus pi over 3, so which is 2 pi over 3. Okay, so if you don't know where 2 pi over 3 come from, you can put in here, this is 120 degree, or you can put as pi minus pi over 3. Okay, so same way it works for radians. It's just you're using different currency, I guess, using different units. So 120 degree or 2 pi over 3 is quite far off from 1080 degree. So what do? Well, keep adding 360, but we don't add 360 in here. In fact, what do we add? We add 2 pi. Okay, so we add 2 pi to both of these answers. So 2 pi plus pi over 3 is 7 pi over 3. Okay, 2 pi over 3 plus 2 pi is 8 pi over 3. Okay, 8 pi over 3, I like to put that in a calculator, which is, I like to put in a calculator. So 8 times 180 divided by 3, or just 8 times 60, which is 480 degrees. So I know this quite far off from 1080. So I keep adding 2 pi. Now you see how I use degrees here and there, but in my working out, I keep using radians. It's just in a little jotting, so it just tells my brain, okay, where 8 pi over 3 is in terms of degrees. So keep adding 2 pi, 7 pi over 3 plus 2 pi is 13 pi over 3. 8 pi over 3 plus 2 pi is 14 pi over 3. 14 pi over 3, 14 times 60, 14 times 180 divided by 3 is 840. It's 840, so do that, 840, 840 degree. Oops, sorry, I should be using green for the color. just to be consistent, 840 degree. 840 degree. If I add 360 to 840, so if I add 360 to it, that's 1,200 degrees. So if I add 360 to 840 is 1,200. That's way beyond 1,050. Okay. Now, what about 13 pi over 3? Okay. If I add 13 pi over 3, you can either change in degrees, okay, or you can just add 13 pi over 3 to 2 pi. You get 19 pi over 3. So 19 pi over 3. So which is 19 over 3 times 180. That's 1,140. So that's going to be beyond 1,080 degree again. So about 6 pi. Or, you know, if you add 2 pi to 13 pi over 3, that gives you 19 pi over 3. 19 pi over 3 is way beyond 6 pi, because if you look at the domain, we need up to 6 pi. Oops. 6 pi. Not the ruler. 6 pi. 6 pi, you know, 6 pi. 3 times 6 is 18, but it's 19 in here, so we know it's beyond, it's bigger than the domain that we allowed. Therefore, I'm going to stop here. We have 6 of the answers that we need, but that's in 3 theta, don't forget. So what we need to do is we need to divide everything by 3. Therefore, I'm just going to be a bit lazy and write on the side in here. Therefore, theta equals, divide everything by 3, pi over 9, 2 pi over 9, 7 pi over 9, 8 pi over 9, 13 pi over 9, and 14 pi over 9. Right, 6 answers. Okay. Right. If you're happy with this, next one. Okay. Example. Again, if you think you know how to do it, you can pause the video and have a go at the question. Okay. Otherwise, I'll be going through it. So example, solve the equation 17 cos theta plus 3 sin square theta equals 30 in the interval of that one. Hopefully you realize we cannot solve this right now without using identities, because sine squared and cos theta, we need to make them into one, either sine, both sine, or both cos in order to solve it. This one, it'll be easier to change them into cos, because I know sine squared theta plus cos squared theta equals 1. Therefore, sine squared theta equals 1 minus cos squared theta. So the first step is I can replace that. So 7 cos theta plus 3 sine squared theta, which is now 1 minus cos squared theta, equals 13. So I have replaced the sine squared theta by 1 minus cos squared theta. Next, I'm going to expand the bracket, and you realize it's a quadratic. So here we go, 17 cos theta plus 3 minus 3 cos squared theta equals 13. Make it look a bit neater. So I'll put negative 3 cos squared theta plus 17 cos theta. Bring the 13 over, becomes minus 10 equals 0. Or you could have the sign changes into 3 cos squared theta minus 17 cos theta plus 10 equals 0. But doesn't matter, because we know we've got a calculator to rely on. The calculator will give you, so that's a disguised quadratic, by the way. This is a disguised quadratic. So you can put some middle steps in here if you prefer. We can let y. Now, this really a preference of yourself. So you can let y to be cos theta and make it into minus 3y squared plus 17y minus 10 equals 0. But I'm not going through that way. So I'm just going to let's say you will find, put a calculator, you should get cos theta equals to 2/3, or cos theta equals to 5. Cos theta equals 5. We have to reject the answer because cos theta is bounded between 1 and minus 1. So cos theta equals minus 2/3. So let's do cos inverse cos of 2/3. As soon as we do inverse, do remember, use the cos diagram. Okay, so as soon as we do the inverse sine, inverse cos, we do the cos diagram. So I put a calculator, okay? Make sure calculator is in radians mode. It's in radians mode because from the question, it tells you we need to put it in radians. Judging by the domain, we have to use radians, okay, radians. So inverse cos of 2/3 when the calculator is 0.841 in 3 decimal places. So theta equals 0.841. Now, where's 0.841 in the cos diagram? So, can I choose a different color? There's so many colors, so many I can choose from. Oh, let's choose a interesting green in here. Okay, so we know that's 0 degree. Okay, 0. Now pi over 2. What's pi over 2 in decimal? So if you do 3.14 divided by 2, that's roughly 1.57. So now you know 0.841 is in the first quadrant. Somewhere here. Right? Now, maybe you should know which quadrant we are reflecting the line in. Cos to be positive, we should reflect in the line in the cos quadrant, which is the one in here, the fourth quadrant. So 0.841. So how do you work out this angle all the way here? Well, we know that's 0.841. What about this reflex angle? Well, this reflex angle is same as 2 pi minus, oops, I shouldn't be writing there. This one is same as 2 pi minus 0.841. Okay, or 360 degree. Think about that. It's similar. So 2 pi. So 2 pi minus 0.841 is 5.44. So your answer is not always in terms of pi. For this one, it'll be in 5.44. We write in 3 SF. Is that the end of the question? From 0 to 2 pi? Yeah, I believe so. From 0 to 2 pi means there only one pair of answers. That's it. Okay. Oh, we do like 3 SF. Usually a question, if they will tell you if they want the exact value or if they want, significant figures. So exam practice, pause the video, have a go at a question, very similar to what we just did. Now giving each solution in terms of pi, so 6 marks. Okay, pause the video. When you're ready for the answer, you can press play. Here's the final answer. So x equals pi over 6 or 5 pi over 6. If you got it right, well done. That's the end of lesson for you. But if you don't, well, or if you wonder how I do it, you can carry on. So first thing I see is a cos squared and a sine prompts me to think about using identity again. Now in the next chapter and the next chapter, chapter 6 and 7, you'll be learning new identities as well. So treasure the time that you only have 2 identities to play with, which is sine squared plus cos squared equals 1 and tan x or tan theta equals sine over cos. So treasure the time, cherish the time that you only got 2 to worry about. Okay, when life becomes complicated from chapter 6 and 7, good luck with it. So first thing, again, I'm going to replace cos squared x as, so we know, let me scratch. So we know sine squared x plus cos squared x equals 1. So cos squared x equals 1 minus sine squared x. So that's what I'm going to do. Okay? I'm going to replace this cos squared x in here. So I'm going to do from here. So I'm going to replace cos squared x, put a bracket, 1 minus sine squared x plus 1 equals 5 sine x. And then expand a bracket, make it into quadratic. So 2 minus 2 sine squared x plus 1 equals 5 sine x. Bring it over, so minus 2 sine squared x minus 5 sine x plus 3 equals 0. Right? And then, again, you don't get any marks for showing how to factorize it. So if you put in a calculator with minus 2, minus 5, and 3 as the coefficient in the calculator, you should get sine x equals to a half, or sine x equals 3, or minus 3. But minus 3, rejected, because sine is bound between minus 1 and 1. So we're going to carry on. So sine x equals a half. So inverse sine, up sine of a half. Put in a calculator, that should give you pi over 6. So pi over 6 is here. For sine to be positive, we should reflect in the sine quadrant, which is here, pi over 6. So to work out the obtuse angle, so we know that pi over 6, that's easy. This one, work this one out. This value is pi. So if I want to do the obtuse angle, I could do pi minus pi over 6. So that's where the formula comes from. To remember, sine angle is work out the angle and 180 minus that one, and then cos is is the negative value. For tan, I can't remember, so I don't use the formula. The reason I don't use the formula is because when the domain is a bit weird, then or if the value in itself in the angle is negative, that confuses people. If you don't know what I'm talking about with the formula, ignore me, okay? But stick with class diagram. So x equals pi over 6, or pi minus pi over 6, which is 5 pi over 6. Let me read the domain again, just to make sure I don't leave out any answers. From 0 to 2 pi, that means I know there's one pair of answers only. So, done, sorted. Okay, that's the end of lesson.